I'm sorry, page 34. We're gonna start at 34. Okay. At this point, we have 3 methods for solving a quadratic. Method number 1, graphing. Pretty time consuming. Number 2, factoring. When we see it, it's quick. We don't see it, it's not quick. Method number 3, quadratic formula. Works every time, but it's long.
It's not really.
Okay. So we need to be able to make a decision about what method we should use for each quadratic. Okay. So let's just have a conversation. First of all, is this one ready for me to solve?
Yes.
No. Or yes.
Yes.
Yes, because it said equal to 0. Okay. So if this were to be factored, we would want to quickly-ish, are those my magnets? Okay, could you put them away then? Thanks.
That's good.
So I was getting rid of a disruption and you decided to escalate it to have the whole class involved. Could you not do that?
Yeah, my bad.
Okay. So if we were going to factor, we would want to quickly think about, do we have 2 numbers that multiply to 14 and add to -9? Do you have a suggestion? Just yes or no? So when I said, do you have a suggestion, yes or no? But I don't agree with +2 and +7. Okay, we know that -2 and -7 would multiply to 14 and add to -9. So then our answers would be 2 and 7. Okay. That one was pretty quick. Okay. Could we have done the quadratic formula?
Yeah.
Yes, but it would have taken a significantly longer time.
So how do we know if we need to do it?
Well, those are things that we need to talk about. Okay.
Yes.
So let's look at like number 2. First of all, is this ready to be solved?
No. To subtract the 18x over.
Now it's equal to 0. Do we need to jump right to quadratic formula? When something looks like this, there's 2 terms, and both of them have they have a GCF. What is the GCF? 2x. So now we're left with 2x minus 9. This is way better than the quadratic formula. Because if 2x equals 0, that means x equals 0. And if 2x minus 9 equals 0, that means x is 9/2. Now, we could have gotten there with the quadratic formula. It might have just taken a little bit longer. Okay. Now, if you don't see the GCF, it would. Okay. All right, is number 3 ready to solve?
No.
All right, so let's go ahead and make it so it's ready to solve. All right, are you thinking of Anything? So I'm not really thinking of two numbers that multiply to +2 and add to -5. And that just doesn't seem like it's a possibility. So with our quadratic formula, and if you need to use the yellow sheets in the middle to help you get it set up, that is fine. Maybe you just need to look at the yellow sheet, but the boxes mean you need parentheses. So -b plus or minus the square root of b squared minus 4ac all over 2a. So would you say that we have 5 plus or minus the square root? Under that radical, do we have 25 minus 8? Okay. What's 25 minus 8? Oh.
17.
17 is a prime number, isn't it?
Yeah.
So we're not going to be able to reduce it under the radical. So we have 5 halves plus or minus radical 17 over 2. I thought you had something to add.
Okay, so we know when to do it because nothing in 2 could go into 5, so we use the quadratic.
Yeah. Yeah, let's look at number 4. Number 4 is ready for us. Now, maybe you're trying to factor and you're like, holy baloney, I am not getting anything to work. You're trying 1 and 6, you're trying 3 and 2, and you're just really having a hard time. Okay? Let's just use the quadratic formula on this and see what happens. Okay? The quadratic formula is always going to work. So if we have x equal, can you not? You not? -b plus or minus the square root of b squared minus 4ac all over. Yeah. Okay, and what did I do in the notes that I'll never do for you again? Oh, he didn't watch the video. Dang it. Maddie, what did I do in the notes that I would never do again?
What? I don't know.
You watched the notes.
Me?
Yeah.
I mean, to be fair, if I had gone, I would
Or
have
never.
Sophia, do you know what I did?
Exactly.
Oh,
Yeah,
Giving
same.
us
I
a
watched
question.
it too. I
I watched it.
what did I do? I sang the song. Okay. So we have -1 plus or minus the square root of 1 plus 48. Is that what that is?
Sure.
Over 4. Oh, this looks like good news, doesn't it?
Oh, never mind.
Well, this is good news because that's
Mm. So we have -1 plus or minus 7 over 4. What this means, since I can take that square root and make it into an integer, we could have factored this.
Oh, yeah.
Okay. Now, we have (1/4 plus 7/4, and we have (1/4 minus 7/4. What is this one? 6/4. So 3/2 is an answer. What is this one? (8/4, right?
2.
So -2.
Holy.
We could have factored this to 2x minus 3 times x plus 2. That's what that means. Okay, now if the factoring isn't going well for you, the quadratic formula takes a little bit more time, but it's gonna get you the answer no matter what. Now, yes. So this is -3x plus 4x. Do you see what I'm saying? Because we have to keep in mind that this 2 is being multiplied to this 2x.
It's a 0.
Yes? Okay, Sophia.
Oh. Number 3 is now. What does that answer mean? Like, what does it do?
So this we could put 5/2 plus square root of 17/2 into our calculator and get a decimal. And that would be the approximate of where it's crossing the x-axis. But like if we took a different color, 5/2 plus radical 17/2, and we put that number in for x, we would get 0. It also would represent, like if we put this in our calculator and got a decimal, that's where on the x-axis this parabola is crossing. Okay, it's just not a nice integer number. Okay. What I want you to do is I want you to look at 5 and 7. Decide if you want to do the quadratic formula or can you factor, and I want you to solve. I'm going to give you 4 minutes. Not yet. I need you to do these 2. And you're only asking because Avery just asked.
He asked in the beginning of class. You said not yet.
This is true. I did. I did say not yet. Do these and then let's go.
Yo.
Oh,
Word up.
Sorry. Did my ring get you?
Yeah.
You weenie.
Yeah.
I called him a weenie.
I know, that's my girl fault.
Okay, you're down to 3.5 minutes. And I gave you 2 minutes. I gave you some nice problems.
Like,
Are we able to use this like this?
Yeah, I can have those for the test.
You can? Like use these. Oh, that's actually. Nah. No.
Yeah.
That's probably explaining why I got 2,500.
I like that.
Daddy, you.
I got mine's cool dog. It sounds like
What is God's thing for you to laugh at? It better be a meal.
You're supposed to be running, kid.
dude, there's like 2 hours. Kate's gonna be like, when we get to dinner. That's not fair, so
Okay, when we set number 5 equal to 0, we get 9x squared minus 64 equals 0. What can we do with that? You really have not gotten the hint. You cannot just blurt out in the middle of class, Avery.
Oh.
Okay. Can we do something with this? Ah, we have a difference of squares. Amelia, how do we factor that? I love it except the squared. Okay, not squared. So x equals 8/3 and negative 8/3. So much easier than the quadratic formula. But if you want to use the quadratic formula, it's totally fine. Raise your hand if you use the quadratic formula.
I couldn't still figure it out.
Did you get 8/3 and negative 8/3?
I was still trying to solve it.
Perfect. Okay. Did anybody figure out if 7 can factor? It can?
yeah. But I should.
It's x minus 7, x plus 6.
Yeah. So x equals 7 and negative 6. Right?
No, it's right. X minus.
How would you do it with the weird formula?
I'm talking about inside of it.
I'm waiting. I am waiting. Okay, are you asking how we would do this with the quadratic formula? Yeah. Okay. Do you have a question? Yes, that's fine. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you would have a positive 1 plus or minus the square root of 49 over 2. So you would have 1 plus or minus 7 over 2. No, this is,
Oh, that's
oh, shoot. Sorry. What's 42 times 4?
168.
So this is 169. So this is 1 plus or minus 13 over 2. So we have 1/2 plus 13 halves, 1/2 minus 13 halves. So this one would be 7, and this one would be -6. Okay, can you please turn to page 36? I am still waiting for you to be quiet. On page 36 and 37, you need to solve those problems. Now, if you solve every single one of these with quadratic formula, it's gonna take you a long time. Please be mindful of which ones you can factor. Like number 1, I think you can factor. I will start there. Okay, page 36 and page 37. Both pages are your homework. Okay. No. When Avery gets back.
No. Oh.